So now in kinematics, you got motion that breaks down into two general categories. You got motion that is at a constant speed, and when it's at a constant speed, that's when we use the v equals d over t, or properly expressed like this. And then you got a motion that accelerates. And when it accelerates, we have to use the other kinematics formulas. So what happens though when we have a mix of both? When we got our v equals d over t, and we have one of the other acceleration formulas. Now by that, I mean in terms of a real life scenario, what happens when I got an object that is at first, or over one interval moving at a constant speed, and then at the other interval, it's accelerating or decelerating? What do we do then? Well, in this case, we're going to combine or treat a problem like this in two parts. The first part, or wherever the constant speed is, we're going to use this formula, and then we're going to combine it with this formula over here. So if we look at this example, where it says a driver is traveling at 18 meters per second when they see an obstacle on the road. The reaction time is 0.8 seconds before they hit the brakes, and that's a key word, before. Once they brake, the car slows down at a constant rate of negative 6.0 meters per second squared. What is the total stopping distance? So if we draw this out, we see that for a fraction of the time, it's going at 18 meters per second, and it's consistent at that speed for 0.8 seconds. So if I'm drawing this like a timeline, okay, here's the timeline. For 0.8 seconds of that, from here to here, the speed is 18 meters per second. Then it slows down. So from here to here, it decelerates. And so we want to know what the entire stopping distance is from here all the way to here. This would be the entire stopping distance. So we're going to measure this in two parts. The first part is, well, how far did they travel during that 0.80 seconds? And since it's constant speed, for 0.80 seconds, we're going to use our v equals d over t. And we're going to solve for distance. Since we know the time is 0.8 seconds, and we have the speed, which is 18 seconds, we can isolate for d. Okay, now for the second part, we know that it decelerates, right? So we're going to have to use one of these formulas over here. Now, which formula we use is entirely based on what we have. So right now, we have a distance. So I'm going to write down. We have the distance of 14.4 meters, which we calculated previously. We have our acceleration of negative 6.0 meters per second squared. And we have an initial speed of 18 meters per second, right? That's how fast it was originally going, right over here. And we know what the final speed is. And people say, well, how do I know what the final speed is? Well, we know what the final speed is because it's going to stop, right? Once it brakes, its speed is going to be 0. So we're going to write our VF here is equal to 0. And so now that distance, 14.4 meters, is the initial distance. That's D1. But what I really want is D2. So I figured out that this part here is 14.4 meters. But I want this section here. So I'm going to erase that part. And if we're really just solving for the second distance where it's decelerating, that is what is unknown. Now, given what I have here, the most appropriate formula to use would be this formula. And I could just isolate for D. So if I go VF squared equals VI squared plus 2AD. Since I know that the final velocity is 0, I'm just going to cross that out right away. So I end up having 0 equals, and then that's VI squared plus 2AD. And if I bring everything to the other side, in order to isolate for D, I would have this. And we end up getting a D2 of about 27 meters. So now for the total stopping distance, so if I re-go to the diagram here, I can say that this is now 27 meters. So for the total distance, right, from here all the way to here, well, we could just add them up. So we're going to go D total equals D1 plus D2. And plugging that into the calculator, we're going to get a total distance of 41.4 meters. In terms of significant digits, we just want 2. So we're going to write 41 meters. And that is the total stopping distance here.